So the video you're just about to watch comes from one of my online preparation courses, either the theory preparation course, or teaching in pool and classroom, or the full IDC preparation course. There's lots more information in the link below, and there's also lots more information at the end of this video. Anyway, enjoy the video. I hope you learn from it, and I certainly hope to see you again soon. Thanks. Okay, let's take a look at what happens when gas gets absorbed into liquids. Now, this is a subject where you often see instructors waving fizzy drink cans in front of their students to demonstrate that bubbles can occur when the pressure is released from the can. Now, it's a great demonstration. It shows that there is gas in the liquid, and it also shows that the gas can come out in a dramatic way. But when you go diving, instead of cola and carbon dioxide, it's more about your blood and nitrogen. Anyway, how does nitrogen get into your blood in the first place? So we'll be taking a closer look at what happens to liquid when gas is forced into it. We'll also take a look at some of the words that PADI might use in their questions. Well, actually in their answers as well, come to think of it. So we'll take a look at the particular jargon that you're likely to come up against when you're looking at this subject. So naturally, the more that you can understand this subject, not only will you be able to get higher marks on your PADI exams, but once you are an instructor, you'll be able to pass this information over to your own students in a really simple way that they can easily understand, whether or not you've got a can of fizzy drink in your hand or not. So let's take a look at a typical PADI type of question. You may remember seeing a question like this before. It's about a glass of water that's sitting in a recompression chamber. The question then goes on to ask what's going to happen if the pressure surrounding the glass is either increased or decreased. Now, if you're not really too sure of this subject, then when you start looking down at those multi-choice answers, you might get even more confused, because this is where new words can sometimes start to crop up. For example, instead of continuing to use the word water or even liquid, the answers might start to use the word solution instead. Other words start cropping up as well, like pressure gradient, saturation, supersaturation, equilibrium. All these words start to creep in. So what we're going to do is take a very simple look at what's going to happen to the water in the glass when gas is forced into it, and we'll also discover what these other words might mean as we work our way through. Of course, the water in the glass is simply H2O, hydrogen and oxygen. But for now, we'll concentrate more on the air that's surrounding the glass, which is, of course, made up of nitrogen and oxygen, and mostly nitrogen. So, as the pressure in the chamber is increased, small amounts of gas from the surrounding air is then forced into the liquid. So already we've got one answer to a common PADI type question. It could be a true or false question. True or false? Gas will get absorbed into a liquid if the surrounding pressure is increased. Now, the answer obviously is true, but we still need to be aware of tricky words or word changes that might crop up, because when we start to think of it, once the gas has been absorbed into water, then strictly speaking it's not water anymore, is it? It's not H2O, it's not hydrogen and oxygen. It's got nitrogen mixed in with it as well. So sometimes the word solution is used to describe the liquid. As far as the question's concerned, it doesn't change anything. It's just another thing that you need to be looking out for. Now, the higher the pressure, the more gas gets absorbed into the solution, although it will still look just like an ordinary glass of water. Actually, this behaviour describes your body when you go diving as well. The liquid is your blood, the gas is, well, whatever you're breathing. So let's say you're breathing air, then nitrogen and oxygen will be constantly in contact with your blood in the alveoli in your lungs. And as you descend, the pressure around you increases more and more, and the gases next to your blood in the alveoli get absorbed. The deeper you go, the more gas gets absorbed. Your body will use up the oxygen, it will metabolize the oxygen, but the nitrogen is an inert gas, and this means that it doesn't react with anything. So it just builds up in your blood and gets distributed to other parts of your body. Now, in the next section of this course, which is physiology, we're going to take a closer look at what effect this nitrogen has on your body. And then in the RDP section, we'll take an even closer look at what happens when nitrogen reaches different parts of your body and leaves different parts of your body. And this knowledge helped PADI to form the Recreational Dive Planner. But for now, let's get back to our simple glass of water in the chamber. The pressure's rising, the gas is being forced into the liquid. The higher the pressure, the more gas goes in, just like when you go diving. Now, looking more closely, and we'll see some of the other words that start to crop up in PADI questions. So we did have a glass of water, or a solution if you like, that took on gas. Now it's full of absorbed gas. And as it's full, we can now call it saturated. On one hand, the gas is being held into the liquid by the surrounding pressure, and on the other hand, no new gas can dissolve into the solution unless, of course, surrounding pressure is increased even more. Then gradually it will reach a new higher level of saturation. Okay, but what happens when the pressure surrounding the glass starts to come back down again? Well, as the pressure reduces, gas will start to come out of the solution. Bubbles will start to appear. And here is where we come across these new words, this new jargon that's really common either in PADI questions or in answers. You know, the words pressure gradient, supersaturation, equilibrium. So to get an idea of the meaning of these words, what I'll do is I'll use them now to describe to you what's happening with the gas which is in our solution and the bubbles that are now forming in our glass. So I'll use those words. So here we go, here goes. Before, the liquid was saturated with dissolved gas. The gas was at the same pressure as the surrounding pressure. But when the surrounding pressure was reduced, it caused a pressure gradient between the dissolved gas and the lower surrounding pressure. This led to a state of supersaturation, where the gas is now trying to get out of the liquid. It's trying to escape the liquid in order to reach a state of equilibrium, which is where the pressure of the gas is the same as the surrounding pressure. Okay, so that's using the words with the analogy bit, you know, the bit about the glass in the pressure chamber. But I'm going to continue to use out these words, but this time to talk about you when you go diving. Because as you start to ascend, the surrounding pressure decreases and the dissolved gas in your blood will want to come out. You will have reached supersaturation and bubbles are likely to form. Now, if you ascend very slowly, then it keeps the pressure gradient between the dissolved gas in your blood and the surrounding pressure small, and gas can safely be eliminated within acceptable limits. The gas is trying to reach a state of equilibrium where it's going to be at the same pressure as the surrounding ambient pressure. Now, technical divers, they often have a lot of gas dissolved in their blood. They will often put in decompression stops into their ascent to keep that pressure gradient small and allow gas to escape safely. Okay, so that's about it. Now, I've added some questions for you, all about all of this in the next section. Now, try not to get super saturated with it, because that might mean that some knowledge might start to leak out, but hopefully you'll get used to know how certain words are used, and you'll also get familiar with the way that gas interacts with liquid whilst under pressure. Oh, by the way, all of this is called Henry's Law. I'm really looking forward to seeing you in the next video.
So welcome to the full IDC preparation course. I'm really excited about this program. The reason why I'm so excited is because it's absolutely jam-packed with all of my wonderful secrets that I teach throughout my whole IDC, which is of course why it's called the full IDC preparation course. So we'll have a little look. The screen we're looking at the moment is called your course player. This is going to become really familiar to you in the next few days. But let's have a look here on the left hand side and we'll find out what's involved down here. So down here we've got our theory topics: physics, physiology, equipment, diving skills, RDP, all that stuff. We'll have a little look a little bit deeper into those in a minute, but I want to talk to you a little bit more about what's in this program. So we scroll down a bit here, we've got PADI standards and procedures, right up to date. You can see the very latest version based on this year's PADI instructor manual. And then when we go down here, we've got some really exciting stuff: teaching in confined water. So this is how to make your confined water teaching presentations really effective and, more importantly, really relevant to your students right from the very start. It's a very powerful way of teaching, I'm going to show you here. Perfect for the real world, of course, but it's also really good for IDCs, and it's great for PADI instructor exams as well. So loads of powerful stuff in there. And scrolling down a little bit further, right down to the bottom, teaching in the classroom. Here, I often get asked, I find people on PADI IDCs, they're really not too sure how to structure teaching in the classroom. It's easier than you think, but it needs to be entertaining. It needs to be full of relevant stuff for your students. And in here, I'll explain how all that works. So let's go right back up to the beginning again and look at these theory topics. Let's see what's in here. We'll pick physics for an example. It's always everyone's favourite, isn't it, physics? So we click on physics and we find that physics is broken down into different subjects here. We'll pick on any one of them. Let's pick on, I don't know, effects of pressure. We'll have a look at effects of pressure. And here we see there's a video playing. So it's a lesson. It's going to last for 15 minutes. It shows you here. I'm going to stop the video. So we're in control. We can stop it, start it. We can get rid of this panel on the left-hand side by clicking these two arrows up here if we want to. Bring it back again. Of course, we've always got full screen, so you can put full screen on, sit back with a cup of coffee and just listen to the whole thing. Gives you, a lot more information. And then what happens, also you've got down here is complete and continue button if you want to, and that will stop the video and take you on to the next lesson. And after all of these lessons, the next lesson always is a quiz of what you've just heard, just to make sure you fully understand it. So here we've got like a question up here, very PADI type question, worded in the way that PADI would word questions. And just like PADI exams, 4 different answers that you can choose from. Find out which one is the one that you think is best suited. And just like on PADI exams, but not like on PADI exams, is if we just pick let's just pick one answer that's the wrong one and click on confirm. We find out it's the wrong answer, but not only that, not only will it tell you what the right answer is, but it will tell you why. So it will give you tips and advice where you've gone wrong to help you succeed. So all of the theory lessons are very similar to this. If we work down, loads of RDP questions, loads of diving skills and environment stuff, loads of videos on there to help you if you're not too sure of how all that stuff worked. When you've done all the theory, gone down here, what we can do then is, if you want to at this stage, go to the final mock theory exams. And here we find right up-to-date theory questions here, all based on like the really the latest questions that PADI are asking on their exams. So here we've got PADI theory mock exam A. We go all the way A, B, C, D, and E, 2022 version. As you can see, all of the questions where relevant are in metric and imperial, so it's really great for anybody. or for everybody, I should say. And then the format and the content of these exams is the same as you'll find on your final PADI IE. The wording's not the same. The wording of the questions aren't the same. That's not the objective of this. It's not to tell you what the questions are going to be. It's just so that you can understand the theory, and not only understand it, but that you can teach it to other people as well. It's another objective of this course, really. Then once you've done the mock exams, you can go to the answer key here, and you can check your answers. And clearly, if you've got some wrong, you don't understand them, or you've forgotten, you can go back to the lessons and catch yourself up again. So you can work at your own speed, your own pace, and it's fun working through it this way. Then we've got PADI standards and procedures. Again, we've got these are all based on this year's PADI instructor manual, so right bang up to date with the new programs that PADI have introduced this year. They're all in here, so you can teach yourself and work your way around the PADI instructor manual. Loads of questions. There's 50 questions, 5 exams here. Each one's got 50 questions on it. Exactly the same format, exactly the same content as the ones you'll find on your final PADI instructor exam. Once you've done those, you can have a look at your answers. You can check them with your answers. So here I've just gone to PADI Standards Mock Exam E, for example, answers. And here you can check your answers, see if you've got the right ones or not. But of course, a standard exam isn't really to do with your knowledge of standards. It's do you know where to find the standards in your instructor manual? PADI call it an open book. You can have your instructor manual with you when you take the exam, and what you really need to do is know where to find the answers in the manual. And to help you there, in this answers document, we've got all of the questions that we've asked before, but not only have we given you the correct answer, but also the page in the current instructor manual as to where you'll find the answer. So you can go back to the instructor manual and find out where to find the answer. So that's standards and theory dealt with. When we go to confined water, this is brilliant stuff here. So teaching in confined water, understanding your students. This really is good, finding out how your students learn, the psychology behind the students, or behind the way that you can teach your students. Or actually, I prefer to word it a different way. The psychology, not the way that you teach it, but the way that they learn it. So we've got like subjects on there, like on psychology, positive coaching, which is a really fantastic way of teaching people, correcting mistakes. And it gives empowerment to your students. It gives them ownership of their own learning, and it gives them empowerment as to the judge of the success is down to the student. So really it is the next thing here, student-centered training. It truly is explaining how we can make our teaching student-centered rather than instructor-centered. And when you start doing that, it's amazing how quickly students learn and how effectively they pick things up right from the beginning. Once again, this is perfect for IDCs and perfect for IEs as well. And of course, really perfect for the real world as well. Teaching in the classroom, I've already explained. It really does explain to you what we need to achieve in the classroom to get your students, in the right direction, and being able to understand and probably relate different subjects to each other. So lots more than that in the program. It's really full of fun. I'm really looking forward to working with you through this. And please, why don't you join our Facebook page? We've got the Prior Knowledge Family Facebook page. If you join that, then you can let me know how you're getting on with this program. So I'm really looking forward to the future with you. Thanks now.